Hi everyone, I'm going to show you guys how to do this MIT question. So we'll have to take substitutions. Well, in MIT exams, you'll have to do this within 5 minutes. Well, there's easier methods to do these questions, but I'm going to give you a detailed explanation of how to do this question with substitutions. So what I'll first take is, I'll take a substitution of x equals tan u to the power half. So it's basically x equals root tan u, right? So then dx over du would be sec squared u over 2 root tan u, right? That's easy, right? If you guys want me to show this, please drop a comment. I'll help you guys out with that. But I'm not showing it because it's easy differentiation, right? So if you go further into your question, we have the integration of 1 over, so x to the power 4 plus 1. Instead of x, I'm going to write tan u to the power half. So if it's to the power 4, you can multiply the powers, so half into 4, right? Which will give you 2. So it's basically tan squared u plus 1, and you have to the power 1 over 4. You have this dot dx. Instead of dx, I'm going to write dx equals sec squared u over 2 root tan u dot du. So let me just erase this, get some more space. So sec squared u dot du over 2 root tan u. Okay, so if you focus on this, you can see we have tan squared u plus 1. So tan squared u plus 1 is sec squared u, right? So we have 1 over sec squared u to the power 1 over 4. So this will give you sec u to the power 2 into 1 over 4. So you can see you get sec u to the power half as your denominator, right? So then you can write 1 over sec u to the power half into sec u to the power 2 over, we can take the 2 outside, we can write it as half outside, and root tan u dot du, right? Okay, so if you have sec squared u and sec u to the power half, you could divide them. You'll have sec u to the power 3 over 2 and sec u to the power 3 over 2. Now you can rewrite this again as sec u into root sec u over root tan u. So it's basically the same thing, because sec squared u divided by sec u to the power half would give you sec u to the power 3 over 2, right? So sec u into root sec u would give you sec u to the power 3 over 2. Same thing. So you can basically write your integral like this now. So going further, sec u is 1 over cos u, and root sec u is 1 over root cos u over, and root tan u is root sin u over root cos u. So now you can cancel off root cos u, and you have the integration of half into 1 over cos u root sin u. Now we've simplified it a lot. Now we could take a substitution of t equals root sin u. Now dt over du equals half. Okay, let me show you guys how to differentiate this. So it's sine e to the power half, right? Half comes down, you subtract the power by 1, and you differentiate over what you have inside. That is cos u. So you get cos u over 2 root sine u. Yeah. So then you can write 2 root sine u over cos u dot dt equals du. Then you go back into your question, you have half into 1 over cos u root sine u. Instead of du, I'm going to write 2 into root sine u over cos u dot dt. Okay, let me just take this section a bit more to the right. Yeah, like that. Okay. Now you can see root sine u will cancel off. The 2's will cancel off. Now you need to integrate 1 over cos squared u dot dt. But we need cos squared u in terms of t, right? So root sine u equals t. Sine u equals t squared. Sine squared u equals t to the power 4. And cos squared u would give you 1 minus t to the power 4. So now you should integrate 1 over 1 minus t to the power 4 dot dt. And 1 over 1 minus t to the power 4 you can write as 1 over 1 minus t squared into 1 plus t squared, which you can write as 1 over half 1 minus t squared plus 1 over, did I say 1 over half? I'm sorry, 1 over 2 into 1 plus t squared, alright? Okay. You can see as you add these together, you take the common denominator, you'll get that. Okay, so now what you have to integrate is, we could take the half out as it's common, and you have 1 over 1 minus t squared dot dt plus half into 1 over 1 plus t squared dot dt. Let me just change the color. So I'm going to write with blue. So how do you integrate 1 over 1 minus t squared? Let me show you guys of an easier method of doing this. Let's take the minus 1 out. Let's factorize the denominator with minus 1. So we have minus half into 1 over t squared minus 1 dot dt, right? And there's a formula when you have something like this. So let's say you have to integrate 1 over x squared minus a squared dot dx. The integration of this is 1 over 2 into a ln x minus 1 over x plus 1. Okay, so if you use this onto the question we have, so how do you integrate 1 over t squared minus 1 dot dt? So you can see, in this case, the value for a is going to be 1, right? Because a squared is going to be equal to 1, so you can just take a as 1. So the answer would give you 1 over 2 ln t minus 1 over t plus 1, right? Easy. But we had a half in front. We had minus half in front. So our answer would be minus 1 over 4 ln t minus 1 over t plus 1. Okay, we'll leave that part of our answer like that because we have another integration to do, right? So how do you integrate half into 1 over 1 plus t squared dot dt? This is really easy. The integration of that is tan inverse t. That's it. Half into tan inverse t. So what would our answer be? It would be half tan inverse t minus 1 over 4 into ln t minus 1 over t plus 1. Now if you want to make this positive, you could just take this minus as a power, right? So it's basically like this. So you could consider this as minus 1 if I write 1 over 4 into minus 1 ln t minus 1 over t plus 1. So the power, you can take this power to the top. So basically you could just write it as 1 over 4 ln t minus 1 over t plus 1 to the power minus 1. So if you have to the power minus 1, t plus 1 becomes the numerator, t minus 1 becomes the denominator, right? So basically you could just write your answer as half into tan inverse t plus 1 over 4 into ln t plus 1 over t minus 1. Okay, and plus c, don't forget plus c. But now we need to put our substitutions back in, right? So we had t equals root sine u, right? And we had x equals root tan u, I guess. Let me just recheck one more time. Yeah. Okay, so then you could write x squared equals tan u, right? So then, how do you find sine u? So if x squared equals tan u, what does sine u equal? You could write x squared over 1 equals tan u. So this is your opposite side. This is your adjacent side. So we need the hypotenuse. The hypotenuse would be x squared plus 1 squared, and you put a square root on it, right? So it's square root x to the power 4 plus 1. This is your hypotenuse. So then sine u is opposite over hypotenuse, right? So it's x squared over root x to the power 4 plus 1. And t equals to root sine u. So root x squared over root x to the power 4 plus 1. This would give you x over x to the power 4 plus 1 to the power 1 over 4. Which is what we had in our question, right? We just had the integration of this without the x. Right, so you could just put t back in and you'll have half tan inverse t, which is x over x to the power 4 plus 1, x to the power 4 plus 1 to the power 1 over 4 plus 1 over 4 ln t plus 1 over t minus 1. So t plus 1 is going to be x over x to the power 4 plus 1 to the power 1 over 4 plus 1 over x to the power 4 plus 1 to the power 1 over 4 minus 1, right? Okay, so now what do you do? So if you have a fraction like that, you could write x plus x to the power 4 plus 1 power 1 over 4 over x to the power 4 plus 1 to the power 1 over 4. You'll have the same thing in your denominator, but it's just the minus that changes, right? So it's x minus to the power 4 plus 1 to the power 1 over 4 over x to the power 4 plus 1 to the power 1 over 4. So these two cancels off. So that just equals to x plus x to the power 4 plus 1 in brackets to the power 1 over 4 x minus x to the power 4 plus 1 in brackets to the power 1 over 4, right? I'm just going step by step so that you guys will understand every single part I'm doing. Okay, so then your final answer, your last final answer would be half into, let me just change the color for that, I'll write in red. So half into tan inverse x over x to the power 4 plus 1 to the power 1 over 4. It's just what do you call it, aquatic root, right? Yeah. So I'm just saying to the power 1 over 4, it's easy to say that. Plus 1 over 4 ln x plus over x minus x to the power 4 plus 1 in brackets to the power 1 over 4. You close your bracket, and remember when you integrate an ln function, there has to be a modulus. I forgot that. Okay. Plus c. This is your final answer. So yeah, that's everything for this question. So if you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Thank you so much. Have a great day.